Welcome to this next video in the series for the APM PFQ exam preparation. Just a reminder that this is not a definitive guide. You shouldn't be relying solely on these videos if you're going to be sitting that exam. The idea is to try and give you some of those concepts and put them in a real life scenario to help you understand how these things fit together and enable your studies to be translated into the real world. So in this video, we're going to be looking at scheduling and how to take our activities, especially our work breakdown structure, and turn that into a schedule of tasks we can apply to the calendar that we can then go ahead and actually put in place in the real world. So first of all, we will need to use some of our estimating techniques to look at each of our activities within our work breakdown structure to decide how long we think each of those is going to take. We're not going to be able to schedule and put stuff in a calendar if we don't know how long it's going to take. So just as an example here, looking at a simple scenario of getting ready for work in the morning or for some event. And there's some things that we've decided are tasks we need to done, such as we need to have a shower, we need to get dressed, we need to iron some of our clothes, we need to make a nice cup of tea, perhaps we're having toast for breakfast, and we need time to actually eat and drink that. And before we travel, we need to do some checks on the car, we need to plan our route, and then of course actually drive to our workplace, our appointment, our holiday destination, whatever it may be that we're planning here. We can quite simply take each of those blocks and add up taking a shower, getting dressed and ironing clothes, and summarize those to say 15 minutes for that block of activities. And that's what we'd see in the work breakdown structure, where we've got the individual work packages under particular task titles. But to schedule, we need individual work packages to have assigned times. So what do we mean when we talk about scheduling? Well, according to APM's Body of Knowledge 6th edition, they say that resource scheduling is a collection of techniques used to calculate the resources required to deliver the work and when they will be required. So they're tying in that requirement for resources directly into the schedule. Now, while they do have to go hand in hand, personally, I find it much easier to look at our activities and tasks and schedule them in, and then to look at the resource requirements and adjust our schedule in line with that. In this video, we're going to be looking at scheduling the activities, and in the following video, we'll look at allocating resources to those. So I prefer to summarize our scheduling as knowing what needs to be done, how long is it going to take, and when do we need to start each of those activities? That's the three things we need to know. Our work breakdown structure tells us what it is that we need to be able to do in order to deliver our project. That comes directly from our scope. It's why the scope document is so important to do and do properly, because it leads on to our risk management, our scheduling, our budgeting, our resource management. All of those things come after the scope. So when we've got our work breakdown structure, just a very simplistic example here, we can start making logical choices about the linkages between these work packages. Now, what I do want to point out is I'm about to put some colours and things on screen to explain this. The colours I'm purely using for illustrative purposes. So looking at my work packages, whatever they may be, I may decide that this work package 1.1 is a starting task. It doesn't rely on anything else being done. I can start that whenever I want to. So I can circle that in green. I can then look for other work packages that rely on this being completed. And for this purpose, I've decided that both of these ones circled in blue, 2.1 and 2.2, both of them rely on that work package 1.1 being completed first. So, okay, so there's a logical order here. So what precedes the blue ones is a green one. So that's precedence. and the blue ones are dependent on the green one being done. This is where we get the words precedence and dependence from. Okay, one has to come before another. Some things are dependent on previous activities. So moving on, I've also looked at 3.1.1 at the bottom here and decided that that also can start anytime I like. It's not dependent on anything at all. So I can start that when I want to. However, 3.2 on the right hand side, that cannot start until 3.1.1 has been completed. So I've got some linkage there as well. And I know this is starting to get a bit complicated with the colours and lines all over the place, but this is just to illustrate where we can start to build these linkages. Next, I've decided that actually this work package 1.2 is dependent on the blue work package 2.1, which is dependent on the green work package 1.1. So I'm beginning to create these chains of logical events here. Okay, so we're beginning to build up this list. And back over on the right hand side, I have said that 3.2 and 1.2 are both required along with 2.2 in order to complete our final work package 3.1.2. So that purple one there is at the very end of our chain. We cannot do that until 1.2, 2.2 and 3.2 have all been completed. It's dependent on all three of those, and those in turn are dependent on other things. It's looking quite messy, but we can clean this up in a moment. What I would suggest is if you're doing it in the real world, you can use post-it notes for each of your individual tasks here. And I've certainly done this in the real world and it's very effective. By using post-it notes, you can pop them all up on a wall or on a table and you can lay them out, and then you can pick them up and move them into a logical order that makes sense following your precedence and dependence requirements. That way, you're not moving things around on screen constantly and trying to make these kind of connections, which is time consuming and it can get really confusing. Good old post-it notes, if in doubt, go back to the old ways. So let's tidy this up then. Remember these colours. We've got 3 blue, 2 green, a red and a purple. We're just going to redraw these in a slightly neater pattern. We said there are 2 green ones that we can start with. They are followed by 3 blue ones. There's a red one and there's a purple one. And we can just redraw in our lines that we've decided between those to show this network diagram. We're starting from greens, we have to do the blues, then the red before we can do the purple. Now we just move from left to right, so start to finish. If you think about a lot of activities you do in the real world, you don't do that. You actually work backwards. If you know you need to be at a location by a particular time, you might go, well, hang on, what do I need to do in order to be there on time? And you work backwards through that process. So what do I need in order to make that red 1.3 successful? I need to do this. And in order for that to be successful, I need to do other things. So often we work from finish to start. And certainly when you're thinking about what time to set your alarm for, you don't just set it and then hope you've got time to be ready for your event, work, whatever it may be. You work backwards from when you need to be there, how much time you're going to need to get ready, then you decide when to set the alarm based on that information. It's a much more logical way to approach things. So this is a fairly simple concept, but it can get quite difficult. So if you want to practice doing this and putting these things into a logical order, here's a few ideas that you could potentially use. Pause the video or come back to it another time and think about arranging something like a holiday or a wedding. All of the tasks, all of the work packages that you need to do in order to achieve that. So start with a work breakdown structure and turn it into a precedence diagram, and then you'll be able to use that for more that we're going to move on to in the video. You might choose building a garden shed or a zombie apocalypse bunker or something along those lines, moving house, moving offices, or writing a new computer game or piece of software. It doesn't really matter what you pick. For this purpose, I wouldn't pick anything too complex, because the more work packages, you'll just spend a long time practicing this, when actually you'll get it in quite a few, just a few steps rather than hundreds of them. But give that a go. It will help you to kind of put all of this lot into practice and understand how it works and figure out your best ways of doing it. What we can do next, though, is we can return back to our work breakdown structure, where we've got our work packages. I've got rid of all those horrible colours that make it look messy. But using our estimating techniques, we can now estimate for each of these. If we've not already done this, we can now make sure that we've got estimates for how long each of these will take. So we know what we need to do, we know the order we need to do them in, and now we're making sure that we know how long it's going to take to achieve that. With those pieces of information, we can make another step, and that is into creating our network diagram with its nodes. So this is particular to project management. There's a number of different ways of doing this, but obviously we're looking at APM. So there's bits of information we are going to either need or to calculate. The duration of each of our tasks. So each of those boxes on our precedence diagram is going to be a node. For each of those nodes, so each work package, how long is it going to take to do it? When is the earliest we could possibly start that activity? When is the earliest we could possibly finish it? When is the latest we must have started it by? And when is the latest it must be finished by? And finally, a thing called total float that we'll look at towards the end of our scheduling activities. To capture all of that information, APM use a handy little box like this. You can see there's abbreviations in there. We're going to write our name of our task or our work package ID across the middle, and then we're going to have top left, we're going to write a number that dictates our earliest start of our task, the duration, how long this task is going to take, and the earliest we could possibly finish this task based on when it starts and how long it takes. Across the bottom, we're going to have the latest we must start it. We're going to have this thing called total float that we'll look at later, and we're going to have the latest we have to have this finished by. So lots of numbers here, and you might be thinking, what's the difference between latest start and earliest start? This will come clearer as we start to work through our example. So we want to use that box on the right there, and we're going to use it to replace each of these boxes on here. This is our order of precedence, and now we're going to start filling in that detail. So we've replaced our first green box. It's still work package 3.1.1 and we've replaced it with one of these network node boxes. We can also replace the next one there. So our two green ones, you can see that the top one there is completely blank except for the top middle box, which has our duration in it. So we know that, our duration of 1. Now that might mean 1 day, 1 week, or 1 hour. You need to ensure when you're doing this that you're using the same time scale for every one of your work packages. Do not mix, this will take 3 hours, that will take 2 days. Do not mix them, because it will get really confusing and your network diagram will not work. Most common one to use is days. So our work package 1.1, we have said that is going to take 1 day to complete, and our work package 3.1.1 is also going to take just 1 day. Let's add on our blue tasks, our work packages, and you can see we've got a duration of 4 for the top one, 2 for the middle one, and a 7 for the bottom one. Now, this is how many days or minutes or hours or weeks that we believe each of these work packages is going to take to be completed. We can put our red one in with our duration of 2 days. And finally, our last one here, our purple one with our duration of 3. I've used these colours purely because it matches the circles that we did earlier. There's no other reason for these colours. So you don't need to do this. There's no reason for your diagram to be coloured at all. Okay, we've got lots of information now. We know what we need to do, we know the order we need to do things, and we've got some durations in there. Now we need to do some calculations, and we're going to run a thing called a forward pass. So we're going to start from the left and we're going to move forward through our project and fill in some details. So the other boxes, you can see there's a reminder at the top right, our top left box, ES, our earliest we can start. Now this is a green box. So we decided that green boxes didn't have a dependent, they didn't have anything they were reliant on. They were not dependent on anything else. So when is the earliest they could possibly start? No prerequisites, we can start it now. Anytime we like, we can just crack on with this one. So we know our earliest start is going to be 0. We've got to wait 0 time, we can crack on. And it's going to take 1 day. Therefore, the earliest it can finish is after 1 day. So that's what our new box will look like. 0 for earliest start, duration of 1, earliest finish 1. How we get the earliest finish is simply by adding our earliest start time to our duration. In this case, it's 0 plus 1 gives us 1. And that's the level of maths that generally we're doing with these things. So don't be put off the fact that there's lots of numbers and it now looks like maths. It's quite simple, fundamental maths we would need. So what about our next task? This is a blue one. This is dependent on the previous task. The previous task, the earliest it could possibly finish was after 1 day. So when is the earliest this task can start? It's dependent on the previous task. Well, the earliest that could finish was after 1. So we can carry that 1 over to be the earliest we can start this one. It finishes after 1 day, so this one can't start. The earliest it can start is after 1 day. So we can just literally carry that 1 from one box to the next because they're directly linked. Because they're dependent, or the blue one is dependent on the green one. So this is the process that we're going to use. Now you'll notice for the blue box at the bottom, 2.1, we know the earliest start is 1. We've got a duration of 4. 4 plus 1 gives us the earliest it could finish after 5 days. This is the maths we're doing. It's really, really simple, and we can carry that through the entire diagram. So I filled in some numbers here. We've got the other green one on here. Again, it's not dependent on anything. It can start at 0 time, a duration of 1, the earliest it finishes. So all of the blues are picking up from their preceding box, that 1 to start with. We've got 1 plus 4 to give us an early finish of 5. In the middle, we've got 1 plus 2 to give us earliest finish of 3. And at the bottom in blue box, we've got our start at 1, duration of 7 to give us the earliest we can finish at 8. So maybe you can already predict what the red box is going to look like. We need to carry that 5 across because the earliest we can start red is when the previous one, that blue one, has finished, and the earliest that can finish is at 5. So the earliest we can start this one is 5. We then got a duration of 2, and that equals 7. So the earliest this can finish is 7. We are now moving on to the last box here, our purple one, which has got a duration of 3. But we have 3 different work packages that feed into this. So before I reveal it, have a little think, possibly pause the video, of when is the earliest we can start that purple task. Okay, I'm not sure if you got there. Some people tend to get it very easily, other people not so sure. So here is our purple box. The earliest we can start this is after 8 days. And the reason for that is because we can't start it until all 3 preceding ones have finished. So the red one is finished after 7 days, but we still can't start the purple one because we're waiting on that blue one at the bottom, 3.2. So where you've got a choice of numbers to carry across on the forward pass, you always pass the highest number. In this case, it's 8. It's not 3, it's not 7. We're passing the 8 across. And then we've got 8 plus 3 gives us our 11. Now this gives us a really useful piece of information. Not only have we got the linkages, not only have we got the durations, but that purple task, if we start the green ones now, we know the earliest possible time we could finish that purple one, which is in 11 days. So how long is our overall project going to be? The earliest we could possibly finish is after 11 days. We need 11 days to do this project. If you've been through this process and your project sponsor or your line manager or your client is saying, I need this done in 5 days, you're going to be looking at this and saying, I cannot do it. It is not achievable with the times I need to do these activities. Something has to change. We either need to change the scope, which means removing some of these tasks to make the whole thing shorter, or we need to make some of these tasks much quicker to achieve, which probably means we need more money because we need more people so that we can do this faster. So really useful bit of information, and it flags up some problems quite early in the planning where we can go, this is going to be an issue. We need to look at possible ways to get around this, or maybe at this point scrap the project entirely. As of recording this, we are into November now, and if we're doing a product launch in time for Christmas, we're going to have a very tight time frame. And if I'm looking at product development and testing, manufacturing and shipping to get into the shops in time for Christmas, it's just not going to happen. So I either need to abandon this project or delay it and to run it for next year instead, but start much earlier. So that's what it helps us with. Okay, so one other thing that this can now start to reveal for us is the concept of a critical path. Now, if you have not come across this term before, it is the series of tasks that must be achieved on time in order to not significantly impact the overall project. They are the most important tasks to get right on time, first time. As a project manager, these are the ones we need to keep our eye on closely. You will start to see, and with experience, it will get easier for you to spot the critical path when you're doing these activities. We said the purple one was reliant mostly on the blue one at the bottom because that's where the 8 passed across. That gives us an indication that that bottom blue one, 3.2, is probably a critical component to get right, because delays to that will delay the purple one. So that would indicate this is part of the critical path. There is a much easier way to identify critical path, and we will come to that. You will notice, of course, that we've only completed half of the boxes here. So we have completed the forward path. Now we need to do the backwards path. Now remember, the forward path is looking at the earliest we can start and the earliest we can finish. The backwards path is going to tell us the latest we are able to finish, therefore the latest we have to start a particular thing from. We already know our project duration is going to be 11 days. We're not going to magically extend the project. Therefore, the latest we are allowed to finish our project is going to be after 11 days. So that purple box, we're just going to copy that 11 down. So the earliest finish and the latest finished is the same. So next we want to do a little bit of maths, and we're going to say, well, if the latest we can finish is 11 and the latest we can start it must be a function of the duration, which is this is 3. So if we do 11 minus the duration, it gives us our latest start of 8. In that box, the finish and start times happen to be exactly the same. But as you'll see as we go through the others, that's not always the case. So let's move on and look at the red one at the top here. And we want to be looking at when is the latest we can possibly finish this one. It's going to be 8, because we're going to pass that 8 back from the purple one into the red one. We've now got 8 minus that duration of 2, which gives us 6. So we now in this red box have a variation between the earliest we can start and the latest we can start, and the earliest we can finish and the latest we must finish. And that difference in this case happens to be 1. And we can continue this backwards from the right to the left, the backwards pass, by passing that 6 from the red box as the latest start to become the latest finish for the preceding one. That's the blue 2.1 box. And we can do that also for the middle blue box by passing that 8 back, the bottom blue box by passing that 8 back, etc. So we can see that from the top we've got 6 minus 4 duration gives us the latest start is of a 2. In that middle blue one we've got 8 minus 2, the latest start is 6. And at the bottom one we've got 8 minus 7 duration, the latest start is 1. So the top box, the difference between earliest start and latest start, 1 and 2, we've got a difference of 1. For the middle one, the difference between the earliest start and the latest we can start is 1 and 6, so that's 5 difference. And the bottom one there, bottom blue one, the latest we can start, the earliest we can start are both 1, so there's no difference in there at all. We can then, of course, bottom left, we can pass that 1 back again. So now for our green box at the bottom, we've got a latest finish of 1 minus our duration. The latest we're allowed to start that is 0. So that tells us that green box 3.1.1, we can start it right now, but we have to start it right now. We can't delay that one because the latest we're allowed to start it is today. So what about this other green one? So we've got the opposite problem here. When we were doing the forward pass, we had to pass the highest number into that purple box. We're going backwards now. So what are we going to pass? Are we going to pass the highest number or the lowest number? Which is going to be most appropriate? In this case, when we're going backwards, we pass the lowest number. If you make a mistake and pass the highest one, it will quite quickly show that you've made an error there. But we want to pass the lowest one, so the latest we must finish this one is 2, and then again we've got a 1 duration in this green box, which means the latest we can start it is after 1 day. So we now know the earliest and the latest we can possibly start every single one of these tasks here. We've still got 1 box remaining, which we can now go and complete quite easily. And this is a thing called total float, abbreviated to TF in our little boxes. But this is the amount of time you can delay a task before it impacts the overall duration of the project. You can think of it as wiggle room. So the amount of space you can move it around in the calendar without it impacting anything else. So one of our tasks takes 3 days to complete, but it has 5 days in which to do it, which gives you some choices. You could start it on the first day. It's going to take 3 days, and you're going to have 2 days at the end this task has been completed for, and you don't need to do anything. Or you could start this task on day 2, and in which case it's going to take day 2, day 3, day 4. So you're going to start it 1 day late and you've got a wiggle day at the end. Or you could start it on day 3, 4 and 5, and therefore you would still have it completed. So you can see that diagram on the right here shows you that actually you can fit that 3-day activity into that 5 days however you want, and you could in fact split it and say I'm going to do it for 2 days, have a day break, and then come back and finish it on another day. You could do that as well, as long as it is all completed before the end of your 5 days. If it pushes into 6 days, it's going to impact the next task that follows it and delay when that starts, therefore delay when that finishes, and there'll be a domino effect of all of your tasks and they will all end up being late. Obviously something we would like to avoid. So we can calculate this total float by simply saying that the latest finish minus the earliest finish gives us that number of days that we can float around. So if we return to our boxes, in this particular instance, we can go our latest finish, which is 8, minus our earliest finish, which is 7. Remember, earliest are at the top. 8 minus 7 gives us 1. So we can write a 1 in that final box at the bottom in the middle there, our total float. We now have those boxes completed. We can return to our diagram. Now we know the maths for that, and we can start filling those in. So with the purple box, we're going to be doing 11 minus 11, which is going to give us a 0. That's quite straightforward. For our red box, we've got an 8 minus 7 is going to give us a 1. And then we can do the blue boxes of 6 minus 5, 8 minus 3, and 8 minus 8. So we can fill those numbers in there. And then, of course, finally, our green ones at the bottom left there is a 0. And then our top left, 2 minus 1 gives us 1. Everything is completed, and this tells us a huge amounts of information about what we are doing. We know what the order is we're doing, how long each takes, and importantly, which ones have to be locked into the schedule. We cannot delay them. We talked about critical path earlier, and I showed you that the critical path was the bottom chain, 311 to 32 to 312 at the end. If you look at the number for the total float, you can see that they are all zeros along that chain, showing that none of those can move without impacting the overall schedule. These are critical that they are started on time and completed on time. There's no wiggle room here at all. If we delay, we impact the overall project. We do not want to be doing that. So this really pops out and illustrates to you that this is the critical path. The other tasks, if we look at the blue one in the middle, 2.2, it's got 5 days in which we can move that around. We've got quite a lot of flexibility there. What we do know is that we can't do all of these tasks ourselves at the same time. So this becomes really useful for helping us decide how many extra people we want when we start looking at resourcing. And of course, resourcing isn't just about people. So now we've got all of this information, we kind of want to put this in something that visually is much easier to look at. So a calendar of some sort. So what we're going to use is a Gantt chart. You might already be familiar with Gantt chart. You may have seen them, etc. And a lot of the time you kind of see the end result of a Gantt chart, but you don't see the work that goes in behind it. So this is just an example that's been pulled out of an older version of, I believe it was Microsoft Project, just because it looks a bit pretty. And we can see down the left hand side all of the work packages broken into their tasks. So we have a green task of design with its individual work packages. We have a orange task of development with its individual work packages. And you can see that these are scheduled in a logical order that comes from the precedence diagram for a certain amount of time, and across the top you can see that this is allocated to a date in the calendar, so work days and times like that. Now on this one you can also see names written against each of those work packages that tell you who is doing that particular work package. So looking at the green section, Jennifer Jones looks like she's doing all of that. She's doing the design of the database, she's doing the software design, she's doing the interface design, and she's creating the design specification. So she's got all 4 of those things to be done, and in this particular case you can see that some of those have started to make progress. Visually, this is much easier to be able to share with your team members, your client, your project sponsor, to say, this is what needs to be done, and this is when it needs to be done, and this is who I need to do it. So it's a really critical communication tool. Now, I did say this is done in Microsoft Project. You absolutely do not have to have access to Microsoft Project or any of those bits of software, because one of the really great things is you can just do this in something like Excel. All this is a graph, and I will show you an example of that in a little while. So one of the things we haven't taken into consideration at the moment, and we're going to look at in the next video, not in this one, is when we look at our resources and the amount of people we've got available. If you think about some of the examples we've looked at, moving house, building a shed, or even our simply getting ready for a job interview kind of scenario, what happens if you've got a staff of 50 people hanging around ready to help you? Well, with our getting ready to work scenario, at the moment, with just yourself, you're looking at having to have the shower yourself and make your cup of tea and iron your clothes and check the car and plan the route. With more people, you would actually, somebody else could be ironing your clothes for you while you are having a shower, while a different person makes your cup of tea, while another person is planning the route. It makes it much more efficient because you can do things simultaneously rather than end to end. So here's an example of that. Just looking at this, assuming we have infinite resources, we have at the top here taking a shower. While that is happening, somebody else can be ironing clothes, somebody can be making a cup of tea, somebody can be making toast, somebody can be planning the route, somebody can checking the tires and refueling. So this project becomes quite truncated because we're throwing resources at it and we can do multiple things at the same time. Now, there are some problems with that, of course, such as you cannot get dressed until take a shower and ironing clothes. Regardless of who does it, you can't get dressed until both of those are done. So we still have precedence in here. And the same with eating breakfast. You can't do that until the toast is made and the cup of tea is made. And you can't drive to the interview until those other things are done. I strongly suggest don't drive to your interview before getting dressed. Not a great idea. Probably won't get the job, very much depending on what that interview is for. So infinite resources really can help us shorten the duration of our project, but of course resources cost money. So there is always going to be this balance between the amount of time something takes and the amount of money it's going to cost for us to be able to do that. So I'm going to flip over now to an example of how this can be done in Excel. Quite straightforward and quite simple, and it's actually how I produced this one we're looking on here, and then we can have a look at that, and you might be able to go away and use that and practice with that for yourself. So here we are in Excel, and as you can see, I have just got basically a list of tasks on the left hand side in a table, and on the right hand side simply a bar graph. That's all this is. So we've got our activity of ironing clothes, taking our shower and getting dressed, again broken down into our task lists with these individual work packages, and just in Excel I can put in the times we're going to start each of these activities based off of our network diagram, and how long, our duration for each of these, and of course here it can be useful just to assign it to an individual team member, whoever that may be. For example, we might say actually Peter is the one who's going to take care of that particular work package. Just using a very simple graph on the right hand side here, you can see it's pulling data from the task name, from the start time and the duration for it in order to produce a bar graph. So you do not in any way, shape or form need specialist project management software to do it. You can just do it like this. And why this is really useful mostly is because it's very visual, it's very easy to interpret. And should, as you go through, changes be required to this, you can just update this data live, and it will automatically change what our Gantt chart is going to look like. And I can just take this Gantt chart, copy and paste it into a presentation, into a report, or wherever it may need to go, and I can use it to explain to the wider team, my clients, my manager, whoever it may be, and show them visually, very easy, what it is that needs to happen, when it needs to happen, and talk about who needs to do it. So communicating with my team, Johnny, I need you to do this activity. This is how it fits in to the wider structure of the project. This is why your task is critical, because if that doesn't get done, this is what it impacts. And that's a really, really important thing in project management, is to ensure that anybody doing tasks understands why it's important, how it affects the overall outcome, and therefore what kind of risks they need to notify of, what the quality requirements are, what's the impact if they go over budget or they finish late. And we'll cover things like the risk and quality in further videos in the future. But all of this is about how to communicate what our schedule is and be able to update it nice and easy. So I hope this video has been useful for you in helping taking you through some of these ideas, a good understanding of the APM approach to doing this scheduling. You can replace some of that stuff with software, but I really would practice doing this stuff manually, because when you do it manually, you will learn quicker, more in depth, and you'll be able to spot mistakes much easier. If you like this video, please do leave it a like. Drop any comments in the comments below, would be fantastic. This video is going to be followed up by another short video that's just going to go into a little bit more depth about a couple of bits like the network diagram that's not at the PFQ level, but might be handy for some of you who may have questions. And then the video after that, we're going to start looking at resourcing and applying resources to this. So thank you very much for your time, and I will catch you in the next one.